Hi guys. Yeah, a lot of people ask me, not a lot of people, but a few people ask me questions about this exam to review, and there's a couple questions that are a little hard, so I thought I'd just make a tutorial like I've been doing. Oh yeah, if there's a tutorial you missed, by the way, then for one of the previous chapters and you were able to finish it, then just hit me up, I can send it to you. Okay, this is question number one. How many ways can you select two books from a shelf of 10 books where order is important? It's a permutation question. It's a pretty standard one. NPR, you got 10 and you're permuting two. So answer is 90. Okay, number two. Let's shrink this down a little bit. Okay, consider electing a president, vice president, secretary, treasurer from a group of 7 people. Complete the following statement. Since the order of members elected is important, yeah, order is important when you have different offices, yeah. Electing members involves a permutation with n is equal to 7 and r is equal to 4 because you got 4 positions. So it's NPR 7 comma 4, and the answer is 840. Okay, next one. Suppose you have a set of cups and saucers which are red, orange, green, light blue, dark blue, and yellow. How many cups do you have? Let's see. 1, 2, 3, 4, 5, 6. 6 cups. How many saucers do you have? Well, they're sets, right? So you got also 6 saucers. How many ways can you have a cup, coffee cup, and a saucer? So for each of the coffee cups, you can pick any of the saucers. So it's 6 times 6. This is the fundamental counting principle at work. 36. Number 4, my favorite Moroccan restaurant offers the following menu: cold appetizer, no choice, spicy carrots, kobiza. I'm gonna butcher this pronouncing, but kobiza, zaluk. Notice here it says no choice. So it comes with all 3 of these things. You don't have a say in the matter. So this is not really the fundamental accounting principle so much because it's just one, right? You could say it is fundamental accounting principle, but it's only going to be one choice for that one. The appetizer, select one: spicy chicken wings, carmula chicken drumsticks. I'm sorry, guys, for my terrible pronunciation. I'm just not even gonna try. 3, 4, 5. You got 5 things, right? Okay, 5 appetizers. Entree, you're gonna select 2. You got free range chicken, baked kefta, shakshuka, and you're selecting 2 of those. Okay, and then dessert, no choice. So again, dessert kind of like the appetizer. You got one thing, but it doesn't matter. It's no choice. So how many different meals are possible if the cold appetizer and dessert are served with all the meals, and entrees are served in the entries in the order of selection? I'm sorry, that says entries, but it might as well be entrees because that's the only one that really matters where you're selecting to. So how do you do this question? Okay, cold appetizer, only one choice. Uh, appetizer, you select 1 from 5, so you got 5 choices there. Entree, you're selecting 2, but they're coming in the order that you order them in. So that's a permutation. NPR, there's 3 to choose from, and you're picking 2 of them. So NPR 3, 2. And dessert, there's no choice, so just multiply by 1 again, which means it doesn't change. Answer is 30. Key number 5. A bag contains 15 pieces of candy. Consider selecting 4 pieces from the bag. Complete the following statement. Since the order of the candy is not important, selecting candy involves a combination where n is the bigger number, 15, and r is the smaller number, the 4. Okay, so you're doing NCR from 15, choose 4. No, guys, remember, anytime you see those red numbers, my numbers are going to be different from yours because that means it's randomized. 1365 is my answer for number 5. Number 6, consider drawing 4 aces from a deck of cards where order is not important. Complete the following statement. Drawing 4 aces involves a combination since, order is not important. Since there are 4 aces in the standard deck carved, n is equal to 4. And since 4 aces can be drawn, r is equal to 4 as well. And if you do anything choose itself, like 10 choose 10, 4 choose 4, million choose a million, that's always just going to be one way. Yeah, because you got to choose all 4 of them. Now, a lot of people get confused about this question. They think, why is the N4 not 52? Well, if you said it was 52, then that would mean you could pick any of the 52 cards. But you don't want to pick any of the 52 cards. You only want to pick aces. Okay, number 7. Consider a bowl containing 120 marbles, and they break it down with the different numbers per each color. Suppose each marble has an equal chance of being picked from the bowl. Find the probabilities. Probability of a cat's eye first. Okay, cat's eye, there's 21. Since round to 3 decimal places. So 21 out of 120 is 0.175. Probability yellow, there's 5 yellow. So that'll be 5 out of 120. That's 0.042 to the nearest 3 decimals. Orange, there are 7 orange. So that's 7 out of 120. It's 0.058. There it is. That's number 7. Number 8. Poker is a common game in which players are dealt 5 cards from a deck of cards. Can be shown that they're okay. You know, this is a standard. Let's just read it to be sure, but this is a standard question we've seen before on the homework. There's 2,598,960 possible poker hands. The winning hands from highest to lowest shown in the table. Find the requested probability and use a calculator. Make sure you follow directions here. It says to show 9 decimal places. You're looking for the probability of a straight. Straight is down here at 10,200 ways, right there, 10,200. So we're going to divide 10,200 by 9,000. I'm sorry, no, 2 million, I mean. I don't know where I'm getting 9 from. I'm trying to type in 2, it's giving me 9. 2,598,960. And we're going to need 9 decimal places of that. So 0.00392464782. That's too many. Yeah, how many? 1, 2, 3, 4, 5, 6, 7, 8, 9. So right here at the 6, but if around that, it's going to become a 7. So 0.0392447. Okay. Number 9. A box contains each of 1, 5, 10, 20, and $100 bills. You reach in and withdraw 1 bill. Complete the following table to list the drawing's possible outcomes, their values in dollars, and the probabilities. So the values, $1 bill gets $1. Oh, thank you for filling that first one out for me. Next one, $5 it gets 5, $10 gets a 10, 20 gets a 20, 100 gets a 100. And the probabilities are all the same, and the probabilities is fractions. There's 1, 2, 3, 4, 5, and there's 1 of each. So it's just going to be 1/5 for every one of those. Okay, now for the expected value is always calculated the same way. You multiply and add, right? So 1 times 1/5 plus 5 times 1/5 plus 10 times 1/5 plus 20 times 1/5 plus 100 times 1/5. And your end result is 27.2. $27.20. Okay. Number 10. Suppose you have 20 quarters, 10 dimes, 10 nickels, 10 pennies. You reach in and choose a coin at random. So you gotta, so that you can give it to your child. What's the expectation? This must be a young child because I don't know too many older childs that would get excited about getting a quarter or a penny. Yeah. Okay, 20 quarters. So let's do the let's make a list of our values and their outcomes. So 20 quarters is 0.25, right? Dime is 0.10, 10 cents. Nickel is 0.05, and penny is 0.01. Those are the values, right? What are their probabilities? Well, you got 20, 10, 10, 10. That's 20, 30, 40, 50 total. So the probability of a quarter is going to be 20 out of 50. Okay. Probability of a dime is going to be 10 out of 50. And then the probability of a nickel is 10 out of 50. And the probability of a penny is 10 out of 50. Right, so you get these are the multiplied values. Just add them up together to get the answer. It's going to be 0.1 plus 0.02 plus 0.01 plus 0.002. And it's 0.132 to the nearest 2 decimal places would be 0.13. What's the most likely is a quarter because you got the most of those. Okay, at this point, I've done half the questions. I'm just gonna check, make sure that I didn't make a mistake somewhere along the lines. Okay, okay, everything's looking good, looking good, looking good, looking good. Okay, sweet. So I'm gonna cut the video off here as well, and then I'll do the second half in a separate video.